Hey, 531. Today we're going to talk about Google's Compute Engine. We're going to go into a little bit about some of the other services they offer, just so we can understand better how they integrate together. We're going to talk about what sets Google apart from the competition like AWS and Azure. And we are going to give a brief tutorial on how we can set up a virtual machine using Google's Compute Engine. So it'll be something similar to what we have the chance to do with EC2 with AWS in our first cloud computing lab. So first we're going to just briefly go over the different options that Google has available. First they have their App Engine, which is typically used for creating websites, and mobile app, and gaming backends for use with RESTful APIs and then the Internet of Things. And then there's the Google Container Engine, which is for containerized workloads and hybrid applications. And Google's Compute Engine, which we're going to focus on today. And that is for creating and running virtual machines. And just a few things that Google offers with that is they have predefined machine types, which allows you to run an instance of a machine with up to 32 virtual CPUs and 208 gigabytes of memory, which is pretty impressive. You can also attach persistent disks, which can reach 64 terabytes in size for one machine. And then they offer solid-state drives as well, which are a lot faster, but they're limited to 3 terabytes in size right now for the beta testing. So a few of the things that help set Google apart are their industry-leading price and performance. And Google charges by the minute instead of by the hour with a minimum of 10-minute increments. And if you have a machine that's running for the entire month, you'll get an automatic discount for having that machine going, and it decreases the cost per minute by about 30%. And Google has fast and efficient networking with their private global fiber network. And then Google is also environmentally friendly. So they have created really efficient data centers, and they use renewable energy to help offset their carbon footprint, and then they invest in other projects that help bring their carbon footprint down to essentially zero. All right, so to compare some of the services that Google offers, we want to look at Azure and AWS, which we might be a little bit more familiar with in this class. So looking at Azure, we can see, they offer very similar services. So with the Google's Compute Engine, Azure has Azure Virtual Machines. And something we might even be more familiar with from the Cloud Computing Lab is the Compute Engine compares with Amazon's EC2, which we use for creating the virtual machine. We use Amazon's Elastic Beanstalk, which compares with Google's App Engine. So that's really helpful with auto scaling and load balancing to help deploy. So briefly wanted to show you as well real quick before we continue on is Google's data centers have it looks like they got a stormtrooper in there too, but they have a street view so you can look and see inside their data center. It limits you on where you can walk around to, but you can see how far back it goes in both directions. It's just a massive data center.
One of the major advantages of using Google Cloud Compute Engine is the high performance and scalable VMs that they offer. Boot times using Google Cloud Compute are on average 4 to 10 times faster than the competition and have the advantage of being built on the same infrastructure of machines and networking that is used for YouTube, Gmail, and other vital Google services. This ensures not only a high level of scalability, but also of reliability, as Google has invested millions of dollars in ensuring that those services never go down or have any downtime. In addition, Google's private fiber network is used to connect to other machines, offering very high transmission speeds and, again, increased scalability. One of the unique things that Google offers is the local SSD performance enhancement, which is essentially a local solid state drive attached to each instance, which allows for very high IOPS, which is input and output per second operations. On average, these with the SSD performance offer 20 times more write and 100 times more read IOPS than standard persistent disks. As more and more people become aware of Google Compute Engine as a service, after all it's only been available to the public for about 3 years, more corporations and individuals are considering switching their virtual machines and computing needs over to this cloud platform. Google offers two primary ways that one can do that. For corporations or people who need to migrate over a large number of virtual machines or have important processes that cannot be disturbed, Google has a number of partners that can migrate these VMs on scale for certain corporations at, of course, a reasonable price. For the rest of us who perhaps don't have a budget or a need for such a service, Google wrote a blog that lists 5 steps to migrating your VMs to the cloud. Step 1 being assess, which is namely take a look at your organization and your applications and evaluate which ones would be suited for migration to the cloud and which ones would not. Some of the applications which they recommend migrating are dev, test and QA, internal web apps, and batch processing. Step 2 is to pilot or take 1 or 2 apps, migrate them to the cloud, and see how the performance is affected, if at all. Step 3 is to move your data over first rather than the apps themselves. Many people move the apps first, but make a mistake in doing this in that many apps have a large variety of dependencies upon the data which they are built. So moving data first allows these dependencies to be resolved smoothly. Step 4 is to migrate the apps themselves. And then step 5 is to optimize your use of the cloud. The redundancy, scalability, add reporting, and also modify or tweak any software or operating system licenses you may need to use for your applications. There are a number of features that Google Compute Engine offers that are highly useful for those looking to set up virtual machines. One of them is the predefined and custom machine types options. You can have Linux and Windows machines and support for those machines as well, or any number of custom distributions or operating systems that you might prefer. Google also offers persistent disks or storage that can be transferred from different images or virtual machines up to 64 terabytes per persistent disk, and these can be configured as either solid state drives or traditional hard drives. Google also has the highest standards in compliance and security and matches the highest standards available in these areas. One of the most interesting and novel functions that they've added is transparent maintenance or live migration of machines, allowing for systems to remain up and uptime to remain constant while also providing maintenance and upgrades on the hardware being used. They also offer batch processing, and for applications requiring a very high throughput, have global load balancing to their different locations around or server banks around the world.
So the Google Compute Engine is, as we know, an infrastructure as a service, and the Google Apps Engine is a platform as a service product. So the difference is the Google App Engine will allocate resources as needed for the virtual machine instances required to run all the web servers and backend needed for your web or mobile app. So this provides a great deal of convenience and ease, as you never have to patch servers, configure anything, spin up new instances to handle increased loads if you have more people visiting your app. So if you create a very successful app, you never worry about increased loads, how many instances need to be up to be able to provide good service levels to everybody. So the App Engine comes with those nice features, as well as gives you some tools to monitor security and to integrate third-party tools like GitHub and a few other really convenient ones. So the difference is Google Compute gives you, as an infrastructure as a service, you can do the same things, but you decide what resources are available. So if you create a very successful app in Google with the Google Compute Engine, and that's where you're going to host it and deploy it, you're going to be responsible for spinning up new instances of virtual machines and servers to be able to handle increased loads. And so if you need an infrastructure that goes beyond application management, Google Compute is probably a better choice. And either way, Google Compute is typically cheaper than the App Engine. And also for pure app management, it's cheaper. However, App Engine does provide that very convenient automation. So there's another service called Google Container Engine, and essentially you can create a Kubernetes cluster or a Kubernetes pod. So a pod is something that holds a bunch of Docker containers. So you create these clusters, and you can control when different Docker containers or Kubernetes pods are run in those clusters and how much CPU is dedicated, the timing of everything. But it's still an important decision between Google Container Engine and the Compute Engine, as they can both run Google's open source container service called Kubernetes. So it's essentially a controller program. It's Google's open source cluster program. It allows you to put multiple Docker containers into a pod and allows all of the Docker containers within a Kubernetes pod to be managed there. It's most effective and easiest to use if you're going to just be running containers, if you do it through the Google Container Engine, but you can also do it effectively on the Google Compute Engine. It just takes a little bit more know-how and attention. So the container, once again, kind of, if you're going to just purely be doing things that pertain to containers, it can be a better decision to go with the Google Container Engine. However, if you need that as part of a larger system, that's just one aspect. It can be a much better choice to go with the Google Compute Engine.
Another good thing about the Google Compute Engine is that it is pretty similar to AWS in its functionality and how you use it. So if you're a professional who's familiar with AWS and used it in the past, using the Google Cloud in general and using Google Compute Engine will be somewhat simple and easy to use. There's documents right here, 2 links of how they compare. We're going to move past those right now and move into a demo that we want to do of starting a VM with Google. We're going to use this link right here if you want to follow along to a quick start. That link will take you to this page. What you need to do first is to click this button, Try It Free, and from there you'll set up an account with Google and enter your credit card information. That they won't charge you because you have a free trial. You have $300 worth of credits and 60 days of a free trial. And so we'll start by hitting this quick start using a Linux VM, and this will show you all the steps that you need to do to create a virtual machine that has a Linux distro on it. So we're just going to come over here. Here is the main page, the home page of the Google Cloud Platform. This is what you'll come to first. As you can see up here in the menu, there are all these different apps. It's kind of similar to AWS in that way. There are different apps that you can use. We're going to use the Compute Engine. You could also have clicked it right there on the home page. As you come here, you can see the instances that I have running on the bottom. We're going to create a new one up top. If you can see this Create Instance button. Now you can name your instance whatever you like. You can choose the zone that it's in. I'm going to choose US West. And you should use most of the defaults that are here so you don't get charged more than you should. And but you can change the image. So if you want to boot in an Ubuntu or any other distro right here, you can. And there's a lot of good options there. We do want to click these 2 options, allow HTTP traffic and HTTPS traffic. And then we want to hit create. Now that'll take us to this page and it's creating the instance right here. One thing I want to note is that Google Compute Engine is very fast in creating these instances. They're better than most of their competitors. So this one should pull up here in a couple seconds. Yeah, it's already up right there. And we're going to go to the first one that I already have open, and you can click right here in SSH. And it'll bring up a SSH window, and you don't have to install PuTTY or anything like that. It's all on its own thing. So this creates a SSH window. You want to click connect. And once it's connected, we will look at a file that I've created, index.html. But after that, we'll just throw up a simple server and we can see our page. So if we want to run, just so you can see what is in this file, it's just a simple HTML. It just has embedded YouTube link, video, I mean. And then we'll do this command, the simple HTTP server command, and it'll throw it up on port 80. From there, we just have to click this link right here to visit your server. And here it is. The video is already here. So that's our tutorial, our little demo, and we'll leave it with this awesome cat video.
Say